Okay. All right, today we're going to talk about simplifying radicals. I know several of you in the class are still learning this skill, so I want to put this video together to make sure that you have all the necessary tools to be able to master this skill and be successful in future assessments. Okay, in order to simplify radicals, first of all, you have to have the perfect squares to help you, okay? And these are our perfect squares: 1, 4, 9, 16, 25, 36. These are not all of them, but these are some. So how do I get these perfect squares? Where do they come from? Well, they come from, if I take the number 1 and raise it to the second power, I get 1. If I take 2, raise it to the second power, I get 3. If I take 3 and raise it to the second power, I get 9. And 4 to the second power, 16, and so on and so forth. Now, we also know that the opposite of raising a number to the second power, the opposite of that is square root. And since we are simplifying square roots, radicals, right, we're going to use those perfect squares to break them down so that we can take the square root of them to simplify them. Okay, so we break it down in parts. So what I mean by that is if I take the square root of 1, I should get 1. If I take the square root of 4, I get 2. If I take the square root of 9, I get 3. So basically what we're saying is if I take a number, raise it to the second power, and if I do the opposite of it, say the square root of 9, I should get 3. That's the number that I use to square in order to get it. Okay? So what we're going to do is we're going to use those perfect squares to expand, break down these radicals. So here's how we're going to do it. And I know some of you are probably looking at it like this. You're probably not going to think through all of these radicals. It doesn't matter where you start. So let's just take, and you have to use the perfect squares to break the radicals down. So we'll start with square root of 4 times the square root of 8. That's 32. Okay? Now, I can take the square root of 4, which is 2. And I'll have 2 on the square root of 8. Now, the question is, are we done with this particular problem? Okay, the 2 outside of the radical, I'm pretty much finished. But now I have to look at the radical, square root of 8. Can I use one of these perfect squares to break down the square root of 8? Sure, 4. So I can break that down. So really what I have is 2 times the square root of 4 times the square root of 2. Because we know that radicals act just like numbers. If I multiply 8 times 8 and get 64, then I can take square root of 8 times square root of 8 and get square root of 64. Okay? They work the same way. All right, so I take the square root of 4, which is 2. So that's 2 times 2 on the square root of 2. And now I'm at a point, all I have to do is just multiply the numbers on the outside of the radical. 2 times 2, which is 4, which is 4 on the square root of 2. And that's the final answer that I need to have to simplify square root of 32 in radical form, 4 on the square root of 2. Now the other problem that we've worked on is when we take the square root of a power. Powers and exponents work very similar. We talked about the numbers under the radical sign. We call those radicands. And then there's the index. And since we're taking the square root of a number, there's no number in the index, but the index is 2. So here's how we do it. Normally what we will do is we'll just take the exponent of the radicand and divide it by its index, and that will give us our result. Okay? But since we have an odd number power, we're going to have to expand, break down these radicals, just like we did in problem number 1. So in other words, perfect exponents are even power exponents, like a to the 4th, a to the 6th, a to the 8th, a to the 10th, a to the 12th. Those are perfect exponents, okay? So I'm going to break these two down to perfect exponents. So I'm going to expand the problem, so it'll be a to the 7th times b to the 5th. So what I'm going to do is I'm going to break a to the 7th down to its closest even exponent. So it's going to be square root of a to the 6th times square root of a. That's my a to the 7th. Remember, these powers, this is called the power rule. when we have like-based powers, we add the exponents. They act just like the numbers do. The radicals respond the same way. So a to the 6th times a to the 1st is going to give me a to the 7th. Square root of a to the 6th times square root of a gives me square root of a to the 7th. Now I'm going to do the same thing with b to the 5th. So that'd be b to the 4th times b to the 1st. All right, now I can take the exponent, or I can take the square root of a to the 6th. So it'll be 6 divided by the index of 2, which is not there, and that'll give me a to the 3rd. And that's already simplified, and the only thing that's left is square root of a. Times, take the square root of b to the 4th, that's 4 divided by its index, which is squared, which is 2. 4 divided by 2 is 2, so that'll be b squared on the square root of b. Now we need to put it in simple form. Since we know that we have a to the 3rd and b squared outside of the radical, we put those together outside of the radical. So a to the 3rd times b squared is just a to the 3rd b squared. The radicals act just like numbers. So square root of a times square root of b is just square root of ab. And we're done with that type of problem. Now the next problem really is an expansion of the first two problems. We don't do anything different, we do the same thing. So what I'm going to do is I'm going to break this down. All right? So I'm going to break this down, and I'm going to use 9. So I'm going to go square root of 54 times square root of b to the 9th. And I'm going to use one of these perfect squares to break down 54. So that'd be square root of 9 times square root of 6. That's my square root of 54. Remember, I have to, this is a perfect square, so I have of b to the 9th, so that means I'm going to go to the highest even power that I can get as close to 9 to start. So that'd be times square root of b to the 8th times square root of b to the 1st. Now I can take the square root. So square root of 9 is 3 on the square root of 6. B to the 8th is b to the 4th times b to the 4th times square root of b. Now I take what's outside of these radicals, put them together. So that'll be 3 times b to the 4th. So that's going to be 3b to the 4th. And 6 times b is 6b. So my final answer is 3b to the 4th on the square root of 6b. So there you have it. This is how you solve radicals. This is how you simplify radicals in simplest form. Thank you.